All right, here we are today talking about toolbox functions, parent functions. A parent function is a function that has, I call it a no-frills function. For instance, in Algebra 1, you learned about linear equations like y equals 2x plus 7. Okay, a slope of 2, a y-intercept at 7. You did stuff like y equals negative 3/4 x plus 1, things like that, but they were all some form of y equals mx plus b. And one of them that you would have graphed was y equals x. Now, this is a y equals mx plus b because the number in front is 1. Otherwise, you would see something else. And the plus b is 0. So this is the parent function y equals x. No frills, no pluses or minuses, no negatives, none of that stuff. And so you may remember how to graph that. You may know exactly what that looks like, and that's great. But if you don't, then we do some t-tables like making negative 1, or excuse me, negative 2, negative 1, 0, 1, and 2. And we plug these in for x right over here. So if I plug in negative 2 for x, I get f of negative 2. Well, let me do the first one. F of negative 2 equals negative 2 if I plug it in for x, right? So I get negative 2. If I plug in negative 1, I get negative 1. If I plug in 0, I get 0. 1, I get 1. 2, I get 2. Let's graph them. Negative 2, negative 2, negative 1, negative 1, 0, 0, 1, 1, 2, 2. This is just a straight line function. Okay? It has a slope of 1. So again, if you go to your y-axis, okay, right in the middle at the y-axis, you're at 0, 0, and you go up 1 over 1, up 1 over 1, up 1 over 1. There's your slope right there. Okay? So we're going to do y equals x squared next. I'll take the same set of points. Not sure why I'm jumping all around here, guys. Sorry about this. Okay? So negative 2, negative 1, 0, 1, 2. And if we plug in negative 2, f of negative 2 equals negative 2 squared. So if you had to take out a calculator right now, you would definitely want to make sure that you put the parentheses around there. Negative 2 times negative 2 is 4. If we do the same thing with negative 1, negative 1 times negative 1 is 2. Or 2. How about 1? All right. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. Let's graph these guys. All right, so here's my points here. You may recognize this function also. This is called a parabola. All right, this is the parent function parabola. And so we would graph that just like that. All right, let's go over to the next one. Absolute value function. Here we go. I'm going to choose the same set of numbers. Negative 2, negative 1, 0, 1, and 2. We'll plug the first one in up here. This is f of x, or f of negative 2, equals the absolute value of negative 2. Remember, absolute value is always positive. It's distance from 0. So if I'm standing at negative 2, how many spaces from 0 am I? I'm 2 spaces. If I put a negative 1 in there, I'm 1 space. If I put a 0 in there, it's 0. If I put a 1 in there, what's the absolute value of 1? It's 1, because 1 is 1 space away from 1. 2 is 2 spaces away from 0. All right, so let's plot those guys. And you get something that kind of looks like a parabola, but this one's a V, not a parabola. Okay, so we get a perfect V on an absolute value. Okay, hopefully you've seen those as well. Maybe you've even seen square root functions. So we'll just take the same set of points. Negative 2, negative 1, 0, 1, 2. Let's plug them in, see what we get. Man, my screen is jumping all over here today. All right, here we go. F of negative 2 equals the square root of, wait a minute, square root of negative 2. We can't do that, can we? We talked about this the other day. So we can't do the square root of -2. This is not possible. In fact, square roots can't ever have negative numbers in them, can they? Those are not real numbers, okay? You can't do the square root of -2. So we can't do -2. We can't do -1. What about the square root of 0? That's right, it's 0. What's the square root of 1? That's right, it's 1. What's the square, wait a minute, the square root of +2? Can I do that? Actually, I can, because it's a positive number. If you were to take out your calculator, you would get 1.41 and a bunch of other numbers on there. But that's too hard because I don't want to take out a calculator. So what I'm going to do instead is I'm going to pick a nicer number, like 3, right? Square root of, oh, wait a minute. Square root of 3 is not nice, so we don't want that. What about the square root of 4? That's right, that's 2. And I could keep going. I wouldn't want to do 5. I wouldn't want to do 6 or 7 or 8, but I could do 9. Square root of 9 is 3, right? Okay, so sometimes it's easier to pick different numbers. Let's plot this guy. 0, 0, 1, 1, and 4, 2. There you go. Rolls right over to the side just like that. Piece of cake, right? All right. Where that graph started at 0, 0, we're going to call that its initial point, 0, 0. On the previous graph, on the absolute value, we actually call that 0, 0 the vertex. And likewise, on the parabola up above, the vertex is 0, 0. Okay? Now, if you call it a vertex on a square root, nobody's going to, say anything probably, but we'll go with that for now. All right? And now what we want to do is we want to transform these guys. We want to change them. That's what transformation means. It basically means you can move it, you can stretch it, you can shrink it, you can turn it, you can do all kinds of things in a transformation. We're going to look at very specific transformations in this unit. Okay? And I'm going to do mine on Desmos.com. So if you have Desmos, you might want to pull that up either on your phone, on a computer, tablet, whatever you want to do. Desmos is very easy to work with. So we have all of our 4 toolbox functions at the top here. And then it says my transformation is going to be y equals f of x plus 3. Well, what does that mean? It means take f of x, which you can see right above here, f of x equals x. Take f of x and simply add 3. So if I take my first one right here, f of x equals x, this is going to be f of x equals x plus 3. That's it. Just x plus 3. The next one is going to be f of x equals x squared plus 3. The next one's going to be f of x equals the absolute value of x plus 3. And the last one's going to be f of x equals the square root of x plus 3. Notice all the plus 3's are outside. They're not really attached to the variable with parentheses or anything like that. Okay? So this is what we're going to graph on Desmos.com. We're going to look at each one of these. But before I do that, the first thing I'm going to do is very lightly graph each one of these parent functions here. So that way we can compare them as we go. All right? So my first parent function was simply that straight line, y equals x. So I'm going to do all those guys in just this light green color so we can kind of see them. Boy, oh boy, sorry about the bouncing around here, guys. I'm not sure what's happening here. All right, so I'm going to go back and I'm going to underline this guy in green so we know that we're looking at the green parent functions. The parabola here is going to be 0, 0. Remember that one from the other side. And what I want you to do here, before I draw the parabola, I'm just going to start pointing some stuff out here. On the straight line, it's easy. It's up 1 over 1, up 1 over 1. On the parabola, look at this one. If I start, okay, let me see if I can get a, I can't do this without, okay, what I want you to look at here is look at the jump between the points. So I'm going to start at 0, 0 here. My first point goes up 1 over 1, kind of like a straight line, but my second point goes up 3 over 1. Okay? We're going to look at that pattern, and you're going to want to know that pattern as we go through and graph these guys here. Okay? And we'll talk more about it when we get to some of the other ones. All right? So here's my parabola, my parent function parabola. All right? And then my absolute value, that one's pretty easy. The nice thing about absolute value, guys, is it's kind of like drawn straight lines. One side, notice the slope on that side. Up 1 over 1, up 1 over 1, up 1 over 1. The right side has a positive slope. The left side goes up 1 and over 1, but it's actually coming down in a negative slope. So one side of an absolute value is positive slope, okay? So slope over on the right side is positive 1. Slope on the left side is negative 1. We'll talk more about slopes too. And then finally, our square root function here, the parent function looked just like this. 0, 0, 1, 1, 4, 2, rolled out to the side just like that, okay? So now we're going to go to Desmos, and we're going to type in each of the parent functions and each of these transformations. Now, I'm going to do the first one, and then I'm going to have you do the ones after that. So let's take a look here. All right, so here's Desmos, and I've got all my functions typed in already. So here's y equals x. Okay, there's my parent function, and here's y equals x plus 3. Those two lines are parallel, aren't they? In fact, the blue line still has a slope of up 1 over 1. Pick a point anywhere on the blue line. Up 1 over 1, up 1 over 1, up 1 over 1. It's crazy, isn't it? Okay, so we still have that 1-to-1 slope on the blue line. Okay, well, that's pretty easy. And notice, instead of a y-intercept at 0, it simply has a y-intercept at 3. So it just starts at 3. Okay, so that's pretty easy. I can do that. I can go up and say, okay, I'm going to start at 3. And again, oops, wrong point. You may remember this from Algebra 1. That 3 represents your y-intercept. So up 3. The number in front of x is your slope, so that's 1. Up 1 over 1. Up 1 over 1. Or down 1 over 1. Down 1 over 1. Look at that. Parallel to the parent line. Piece of cake, right? Let's go back and do x squared. All right, let's take these guys off. Here's your parent function for x squared and x squared plus 3. Check it out. What happened? The vertex down here went up 3 units, didn't it? Now, remember that pattern I talked about originally on the parabola. Take a look at this. Look at the green parabola, the parent. Up 1 over 1, up 1, 2, 3 over 1, and I land at 2, 4. All right? The pattern on the purple one, from the vertex, up 1 over 1, up 1, 2, 3 over 1. Same exact parabola, same exact pattern. The only difference is it started at 0, 3 instead of 0, 0. Okay? In fact, another way to look at it, look at your parent parabola. Look at the vertex here and the vertex on the new one at 0, 3. All that vertex did was go up 3 units, right? Go to the right side of the green, the parent parabola, 1, 1. Take a look at that point right there. That point, count up 3. 1, 2, 3. And I'm on my new parabola right here. Each of the points on the purple shifted up 3 units from the green one. Okay? So we're going to go back. We're going to graph that one. And we'll go start at 0, 3. So I took my vertex and I literally shoved it up 3 units. I can do the same thing with the other points. I'm going to take that point at 1, 1 I'm going to push it up 1, 2, 3 units. I'm going to take that point at 2, 4 on the green graph, push it up 1, 2, 3 units. And I'll do the same thing on the other side, up 3 units and up 1, 2, 3 units. This one's a little goofy because it goes off, but that's okay. And again, notice the pattern of points on the new one. Starting at the vertex, up 1, over 1 to the right, over 1 to the left. Go up 3, over 1 to the right, up 3, over 1 to the left. The pattern doesn't change, not yet. Do you think you know what the next graph looks like? Give it a shot. See what you can come up with. Absolute value. Here we go. There's the parent. There's the new one, up 3 units. Hopefully that was your guess. Easy, huh? So the vertex shifts up 3. You'll notice on that other graph, the 2 lines are parallel on either side, the 2 rays, so it still has the same slope, up 1 over 1, up 1 over 1, to the left, up 1 over 1, up 1 over 1. So the left side has a -1 slope, the right side has a +1 slope. Done. Do you think you can do the square root function? +3 means everything goes up 3. 1, 2, 3. Go to the next point, up 1, 2, 3. Go to the last point, up 1, 2, 3. And done. Okay. Now look at the square root function. Remember the pattern we talked about on the parabola? Go back to the parabola for a minute, the green one. Up 1 over 1, up 3 over 1. A square root function kind of looks like a parabola tipped on its side, right? Or at least half of a parabola. Look at the pattern. Up 1 over 1, up 1 over 3. The pattern reverses from the parabola. Okay, kind of keep that in mind. That's a nice one to know there. All right, so what I want you to do is, you don't have to graph these on Desmos unless you feel like it would help you, but I want you to graph the next set of these. All right, so here we are with each of these graphed, and I purposefully didn't graph the parent functions because I think once you see this, this one's pretty easy. Okay, so the graph of y equals x minus 2 has just dropped 2 units from the parent function. Remember, I didn't graph those here. The graph of y equals x squared minus 2 has dropped 2 units from the parent function. And again, you can always see those parent functions right up above. The graph of y equals the absolute value of x minus 2 has dropped 2 units, and the graph of the square root of x minus 2 has also just dropped straight down 2 units. So this value that we see out here, if you look at the explanation down here, it says the graph of y equals f of x plus k. All right, that's that k value, and in the standard form, that k is going to be a very standard variable right there. So this is a vertical shift, and it's either going to go up or down. It's going to go k units up when k is positive, so you saw that in the example above, and k units down when k is negative, and that's the examples, the 4 we're looking at down here at the bottom. This type of transformation is a vertical shift. All right, so I will see you on the next one. Have a great day.